Tired of juggling input references in every script? In this video, we will explore advanced techniques how to use Unity's new input system, default one in Unity 6, build centralized input handling in a game controller, use a singleton for access, and ensure clean and scalable code for larger projects. Let's get started. Before we dive into advanced usage, here's a quick refresher. Unity's new input system uses input actions which let you define bindings and actions in an organized way. I have a video prepared about basics of input system linked in the description. Here I've set up a few actions for movement, jumping, and attacking. Now, instead of directly handling these actions in every script, we'll centralize everything in a single input manager. I will quickly create an input manager as an object in our scene. Let's start by creating an input manager script. Add component, input manager, new script, and create an add. This will act as a centralized place to handle all inputs in the game. I will quickly create a singleton. To do so, I need a few things. Instance of input manager, private one. Public property of this instance, and creating an instance in the awake method. Let's start by the first one. Private static input manager instance, and a public accessor to it. Public static input manager instance. And I will have to create a getter. If instance is null, we have to communicate an error. And if not, we will return an instance. Then in the awake method we need to create it. If instance is null, it means it wasn't initialized previously. So we make sure that instance is equal to this. And to make sure that this object won't be destroyed on loading, we'll have to use this function. Else, it means that our singleton is already loaded and we have to destroy another object, because we don't want to have few singletons at once. And just like this, our singleton is ready. Now I will need a player input actions class, which is auto-generated by Unity from our input action asset. Quick reminder how to do it. We go to the assets folder and click on the input system actions. Then we choose generate C# class and click apply. And just like that, our class is ready. Now we need to create this input actions reference. It will be private, input system actions, and inside the awake method I will create it. And inside on the enable function, I will enable it. Now that we have input manager, we can easily access input in any other script. For example, let's create a player controller script to handle movement and jumping. Here, I already have a standard player controller script, which has a move, jump, and attack empty functions. I will not be implementing these functions because the video is not about movement, so that's why we will be having a debug log. Now, our movement input should be read every frame, but the jumping and attacking will occur only every now and then. That's why for that we will create events. For attacking, we will use a performed event in the input system. Not for jumping, we will be checking every frame whether the button was pressed. It's up to you. Let's create it. First of all, I will create a function for our movement. Public vector 2 get movement input. And I will be checking input actions player move read value vector 2. By vector 2, it was explained in the video about basic of input system. Check the video linked in the description. Then I will create two events for attack and the same one for on jump. Now in the on enable function, I will subscribe for player attack performed and I will use a function inward attacking, which I will create quickly. And inside it, I will invoke on attack, just like that. In the onDisable function, I have to unsubscribe from this event just to make sure our code is clean and bug-proof. Input actions, query, attack, and the same one performed, and we will unsubscribe from it, just like that. Now, in the update function, I want to check if the player is jumping. For that, I will need an input action, player jump triggered. And I will invoke a jump event. Just to make it cleaner, I will introduce a method for it, and it will be isJumping. And now it's ready to be used in our player controller script. By centralizing input handling in Input Manager, we don't have to deal with input actions in binding in the player controller. It makes the code cleaner and reusable. Let's implement it. In the onEnable function, I will subscribe to our events, just like Input Manager instance onAttack is equal to attack, and Input Manager instance onJump is equal to jump. Here we can see that it was implemented in a different way, but we are using it in the same way in our player controller. For the movement, we will be reading an input, vector2 input is equal to Input Manager instance, and just like that, it's ready. Let's test it out. When I press a left button on the mouse, I can see an attack, and when I press space, I can see a jump block. And of course, I can move my player. And that's exactly what we needed. Let's make this more advanced by adding context for different game states, like gameplay and UI. This ensures input is handled for only what's needed. Because, for example, in our input system actions, we have two different maps. And for attacking and the UI click, we have the same bindings. And to make sure there is no conflict, we have to handle this accordingly. In our input manager, let's create two public methods. One for switch to gameplay, and one for switch to UI. And inside it, we will disable and enable action maps accordingly. Now we can switch context dynamically, for example, in a game manager script. This setup prevents inputs from overlapping, for example, disabling player controls while in a player menu. And here are some tips to optimize and debug your setups. Use Unity's input debugger to monitor bindings and actions. Disable unused actions for better performance. Test different contexts sharply to avoid conflicts. Make sure to keep the singleton lightweight and only enable actions that are necessary for the current context. And there you have it, a centralized input manager using Unity's new input system, complete with context, events, and scalable design. This approach keeps your project organized and ready for growth. If you enjoyed this video, don't forget to like, subscribe, and hit the bell for more Unity tips and tutorials. See you in the next one. Ciao!